Probability. It's the number of desired outcomes out of the total number of outcomes. For example, what's the probability of rolling a number greater than 4 on a fair six-sided die? You could roll a 5 or a 6. So that's 2 outcomes out of the total 6 number of outcomes. So 2 to 6, which is 1 out of 3, which is 0.33 repeating, which is 33.3%. Experimental probability, the number of observed desired outcomes out of the total observed outcomes. When rolling a fair die 60 times, Zena noted that the number greater than 4 came up 25 times. So I ran that experiment 60 times, and I noticed 25 times I got a number that was 5 or 6, which was equal to 0.416 repeating, or 41.66 repeating percent, which is 0.416666666, or 41.66%. Notice that it's different. 60 times rolling a die, that's really not a lot, but if I repeated this experiment, let's say 1,000 times, I'd expect that my experimental probability would be closer to my theoretical probability. I tried it out. I rolled it 1,000 times in a spreadsheet, and 338 times I got a number that was greater than 4, so 5 or 6. So 338 out of 1,000 is 0.338. Look at this, 0.33, getting closer, or 33.8%. As the total outcomes approaches infinity, out of the total observed outcomes, you run it, let's say, 1,000,000 times or 1,000,000,000 times, the experimental probability are going to approach theoretical probability. As the total number of outcomes approaches infinity, theoretical probability approaches experimental probability. This is called the law of large numbers. If you do it a small number of times, you're not going to get theoretical probability. But if you run it a lot of times, yeah, on average, you're going to expect this to come out. Subjective probability. That's when somebody is making a judgment. This is based on judgment, not necessarily purely on mathematics. If somebody says there's a 60% chance of showers on Thursday evening, yeah, they're looking at a lot of different things. They're looking at a computer model, and they're looking at what the weather's doing right now. They're basing it on their judgment. There is a 1 in 300,000 chance of an asteroid colliding with the Earth within the next year. Asteroids can be different sizes. We're not talking about an extinction event, but you might have a small asteroid that could hit. There's a 1 chance in 300,000. There's a 1 chance in 1.2 million. 1 in 1,200,000 chance that the plane you just got on, that it will crash. It's not going to happen. This is practically zero. That's subjective probability. Like, nobody's out there actually crashing planes to see how often it happens. They're looking at the probability and using some judgment. Odds for the desired outcome out of the undesired outcomes. So the number of desired outcomes out of the undesired outcomes, that's odds. So what are the odds of rolling a number greater than 4 on a six-sided die? Well, there's only 2 numbers greater than 4. Then what are the undesired outcomes? Well, rolling one that is not greater than 4. Rolling a 1, 2, 3, or 4. There are 2 that are desired and 4 that are undesired. The odds are 2 to 4, or 1 to 2. We reduce it, and we would read this 1 to 2, 4. The odds of rolling a number greater than 4 on a die is 1 to 2. The odds against is just the opposite. It's the undesired outcomes out of the desired outcomes. Same example, it would be 4 to 2. What are the odds of not rolling a number greater than 4 on a fair-sided die? 4 to 2 against. 4 to 2 reduces to 2 to 1. So we'd read this as 2 to 1 against. An example, the odds that Serenity will win the Trafalgar Golf Tournament are 4 to 3 for her winning. Okay, so that means the odds of her losing would be 3 to 4 against. The odds of Serenity losing the tournament are 3 to 4 against. The probability that Serenity will win the tournament are therefore 4 to 7. Think about it this way. If there were 4 games that she wins out of 3 games that she loses, that means in total there were 7 games. So you would add these two together to get the total number of outcomes. The probability of her winning would be 4 out of 7, where the odds of her winning would be 4 to 3. The probability that Serenity will not win would be 3 out of 7. Betting and odds. Okay, the odds that Traf will win the next football game are 5 to 4. A person is betting $10 that Traf will win. How much can they win? Or how much will they win when Traf wins? We have 5 to 4 is 10 to what? The what amount is what they're going to win. 5 to 4 is 10 to our unknown. I'm going to, just to get the unknown alone on top, I'm going to switch it with the 5 and cross multiply the 4. So we have 10 times 4 is 40, divided by 5 is 8. The winnings would be $8. How much could they win if they bet against Traf? So if you bet against Traf, it would be 4 to 5 against, which would be 10 to what? Cross multiply, switch the 4 and the winnings, and cross multiply the 5 times 10. So we have 50 divided by 4 is 12.5. A person betting against Traf could win more, but the probability of them winning, of Traf winning, is high. So this person, the probability of them winning $12.50 is low. The probability of Trav winning is 5 out of 9, which is 55.5%. The odds of this person losing is going to be 44.4 repeating percent. Mathematical expectation lets us know whether a game is fair or unfair. It's the value of the random number coming up times the probability of getting that number. Let's say you're playing a game where you could win, you have a spinner and you have different sectors. You could land on a 2, you could land on a 3, you could land on a 5, or you could land on a 7. And let's say the odds of landing on the 2 were, the probability of getting the 2 was 15%. The probability of getting the 3 was 20%. The probability of getting a 5 was 25%. The probability of landing on the lose $7 was 40%. It's a bigger slice. And you spin that spinner. What are you going to expect to win? So we're saying that it's going to be the $2 times the probability of winning the $2. So it's going to be 2 times the probability of winning the 2 times the 15%, plus 3 times the probability of winning the 3, which is 20%, plus $5 times the probability of winning the $5, which is 25% or 0.25. And 7 times, now losing 7 is minus 7, right? That's why it's minus, because it's losing. So minus 7 times the probability of losing 7, 40%. Or 0.4. Take a handy-dandy calculator. 2 times 0.15 added to 3 times 0.2 added to 5 times 0.25 added to negative 7 times 0.4. And that gives us negative 0.65, which means every time you play, on average, let's say you play 100 times and you averaged out all your winnings, you would actually be behind by 65 cents per game. If you played 100 times, you would be down $65. So the expectation is low. So on average, you would expect to lose 65 cents per game. Mathematical expectation, we're still talking about fair versus unfair. Here's our example. On a roulette wheel, a winner gets 35 times the amount that they bet. Slots are numbered from 0 to 36. That's 37 different slots. So the probability of it landing on their number that they pick is 1 out of 37. So the probability of winning is 1 out of 37. That means the probability of losing is 36 out of 37. A person is betting $10. What is the expected gain? Okay, so if they win, they're going to get 35 times 10. They're going to get $350. We're going to take our 350 and multiply it by the probability of getting $350, which is 1/37. So 350 times the probability of winning $350 is 1 out of 37. And then we're going to add to that, the person is losing their $10 in all other cases. The probability of losing $10 is 36 out of 37. All right, so let's do that calculation. 350 out of 350 times 1 out of 37. Take away 10 times 36 out of 37 is equal to negative 0.27027, which means you're going to lose 27 cents on average, which isn't that bad. On average, we would expect to lose 27 cents. If you were playing 100 games, you'd be out $27 on average. On average, we'd expect each game to be losing 27 cents. But the expectation is greater than 0. The advantage goes to the player. It's more than fair. It's better than fair. If the expectation is 0, well, that's a fair game. The amount that you win is equal to the amount that you lose. If the expectation is less than 0, that means you are losing more than you win. That would be an unfair game. It would be a disadvantage to the player. And that's mathematical expectation. Have a good day.